This is SpaceTime Series 29, Episode 75, for broadcast on the 24th of June 2026. Coming up on SpaceTime, the Moon's oldest and largest impact crater, new clues about how the red planet Mars evolved, and NASA's new mission to boost the Swift spacecraft back into a higher orbit. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests that the Moon's oldest and largest impact crater, the 2,500 kilometre wide South Pole-Aitken Basin, could have excavated material so deep it included parts of the Lunar Mantle. The findings, reported in the journal Science Advances and Geophysical Research Planets, provides fresh insights into the early evolution of our solar system and what the Artemis astronauts will encounter when they land at the lunar South Pole in 2028. One of the study's authors, William Bottke from the Southwest Research Institute in Boulder, Colorado, says the collision struck the lunar surface with so much force that it may have excavated material from deep inside the Moon, including portions of the lunar mantle. Using advanced models and simulations, Bottke and colleagues recreated the crater-forming impact and identified new evidence about the direction and composition of the impact that struck the Moon. Their work shows the best fit was an impact approaching from the north and travelling south, hitting at a low angle and producing the elongated, tapered shape of the basin. The modelling suggests the impactor wasn't a simple uniform body, but a differentiated object with an eyeing core surrounded by rock. In other words, it could have been a small protoplanet or a large differentiated asteroid. As the impactor slammed into the Moon at a low angle, it excavated a deep asymmetric cavity and melted the rock in the central basin. The collision lofted large amounts of material from both the lunar crust and mantle, which later settled back onto the basin floor. The authors also analysed how this ejector would have been distributed beneath and around the basin. They compared high-resolution gravity data with models that included both crustal and mantle material, determining that the basin likely contained substantial amounts of mantle-derived rock within its interior and mixed into the ejector blanket surrounding the crater. A few subsequent impacts within the basin appear to have later excavated these underlying mantle deposits, bringing some of this material to the surface, where it's lying there ready to be sampled by robotic rovers or people on future missions. Earlier theories had suggested that the deepest ejector might be confined to parts of the basin far from the proposed South Pole exploration zones. However, these new simulations and gravity modelling indicates that key deposits of mantle-bearing ejector may well blanket portions of the lunar South Pole, right where the astronauts will land. The research is fascinating because it's telling mission managers exactly where to look for samples which could answer some of our biggest questions about the Moon's origin and evolution, and consequently about the evolution of the inner solar system. This is SpaceTime. Still to come, new clues about how the red planet Mars evolved, and NASA's new mission to boost the Swift Space Telescope up into a higher orbit. All that and more still to come on SpaceTime. Scientists have discovered the mineral Garnet in a Martian meteorite, and these findings may help reveal how the red planet evolved billions of years ago. You see, Garnet is a completely new type of rock from the red planet, and it offers a rare glimpse into the ancient Martian past. The findings, reported in the journal Geochemical Perspectives Letters, could help researchers piece together the planet's 4.5 billion year geological history. It offers a new time capsule, preserving clues about the temperatures, pressures and processes that shaped the red planet billions of years ago. Garnet is a dark red gem. It was popular in ancient Egypt with the Romans and with the Victorian elite. It's also the January birthstone. And it's a cornerstone mineral in geology, providing a powerful record of the tectonic forces, ore-forming processes and fluid-rock interactions that shaped the Earth's crust and mantle. One of the study's authors, James Darling from the University of Portsmouth, says the findings add striking new dimensions to science's understanding of the geology of Mars, and they open up a new window into its evolution. Garnet-bearing rock could provide clues about how Mars has changed throughout its history and provide new insights into the ancient environments that could have formed the garnet and related minerals. The garnet was discovered during an analysis of a fragment of a Martian meteorite known as NWA 8171. Now, the authors originally thought the sample was simply common pyroxene, but a more detailed examination using electron microscopy and microanalysis discovered it to be garnet, a mineral that had not been identified on Mars before. Garnet is a classic example of a mineral often found in metamorphic rocks on Earth. The process of metamorphism transforms igneous or sedimentary rocks into a new form through exposure to extreme heat, high pressure, or hot fluids. On Mars, the heat and pressure needed to produce garnet through metamorphism could have come from the impact of a meteor hitting the surface, or from magma rising up into the crust, or from both. However, the authors admit they can't rule out that the garnet-bearing rock may well have been delivered to Mars and incorporated into its surface through a meteor impact. So the authors now need to study the garnet's isotopic signatures in order to verify whether it was originally produced on Mars or whether it came to Mars and consequently came to Earth from another body. Measuring oxygen isotopes from the garnet-bearing rock itself would help to confirm its origins. And needless to say, we'll keep you informed. This is Space Time. Still to come, NASA's new mission to try and save the Swift Space Telescope by boosting it into a higher orbit, and later in the science report, discovery that humans were already using fire between 1.07 and 1.79 million years ago. All that and more still to come on Space Time. NASA's about to launch a new mission designed to extend the life of a $500 million spacecraft by boosting it into a higher orbit. Catalyst Space will use its Link rescue craft to boost the orbit of NASA's Swift Gamma-ray Space Telescope. Swift was launched back in 2004 to study changes in the high-energy universe, things like gamma-ray bursts, which are the most powerful explosions in the cosmos. See, when a rapid, sudden event takes place in the sky, Swift acts as an early warning system, providing crucial information that allows other observatories to follow up and learn more about the event and consequently how the universe works. But after 22 years, Swift's 600-kilometre high orbit has begun to decay rapidly because of increased solar activity. NASA initially expected it to stay in orbit until the early 2030s, but the latest peak in the Sun's 11-year solar cycle was far stronger than expected. Increased solar activity heats and swells Earth's atmosphere, and that creates extra atmospheric drag on orbiting spacecraft. And that atmospheric drag will cause spacecraft orbits to decay, ultimately burning up in the atmosphere unless they're boosted back up into higher orbits. For Swift, that wasn't possible, and mission managers realised the telescope was doomed in a matter of months. It's now just 370 kilometres in altitude and will soon suffer enough orbital decay to re-enter the atmosphere and begin burning up. But rather than allowing the mission to end, NASA decided to take this opportunity to test a new spacecraft specifically designed to attach to Swift and boost it back up to its original orbit. In September 2025, NASA awarded a contract to Catalyst Space to mount a robotic servicing mission to Swift in less than a year. The mission will use a 400-kilogram refrigerator-sized robotic rescue craft called Link to rendezvous with Swift and boost it back up into a higher altitude. Link will be launched aboard a Northrop Grumman Pegasus XL rocket. The Pegasus will be taken up to an altitude of about 45,000 feet, attached to the underbelly of the converted Lockheed L-1011 airliner Stargazer, which will take off from a runway in the Marshall Islands. Once the airliner reaches the correct altitude, Pegasus will be released, ignite its own engine, and climb into space. Once in orbit, Pegasus will deploy the Link rescue craft, which will then attempt to rendezvous with Swift, taking images of the spacecraft from different angles so mission managers can inspect the aging probe for damage from debris and micrometeorites and work out how they're going to capture it. Link will then attach to Swift using its 3 robotic arms, and gradually over more than 6 weeks, it'll use its thrusters to slowly boost the observatory back up into its 600-kilometre high orbit. It's a mission that might not only save the spacecraft, but demonstrate the possibility of extending the lives of other spacecraft through boosting, refueling, or repair work while in orbit. This report from NASA TV.
NASA is working with an American startup to attempt something no one has ever achieved. Boost a spacecraft before it re-enters the atmosphere.
This is just a really different kind of mission. We can't wait long.
Its orbit has been lowering. If we do nothing, Swift will re-enter the atmosphere, and so there's nothing to lose.
Just a few months ago, this spacecraft was a conceptual drawing.
Catalyst's robotic spacecraft will approach the observatory, carefully capture it, and propel it to nearly its original orbit.
6 months ago, this was a PowerPoint. In under a year, we're going from identification of a problem, proposal, contract award, to launch.
Saving Swift isn't about just preserving one mission. It's about moving forward in a future where we can give spacecraft a second life.
And in that report from NASA TV, we heard from NASA Swift scientist Brad Senko and Regina Caputo, Catalyst CEO Gonhee Lee, and Catalyst Link lead scientist Karen Wilson. This is Space Time. And time now for another brief look at some of the other stories making news in science this week with a science report. The World Meteorological Organization has released its latest State of the Climate in Asia report, showing that ocean surface temperatures have now reached a new record. The study found the seas of Asia had warmed faster than the global average, with a mean surface temperature of around 0.96 degrees Celsius above the 1991 to 2020 average, with China, Korea and Japan all recording their hottest summers on record. Pakistan, Sri Lanka and Vietnam experienced devastating floods and monsoons and tropical cyclone-related rainfall, with over 1,200 deaths from flooding in Pakistan and Vietnam alone. A new study has found that people tend to undergo changes in their brains within a month after their first psychedelic experience from magic mushrooms. The findings, reported in the journal Nature Communications, involved 28 healthy people who had never taken magic mushies before and scanned their brains within an hour of a single high dose of psilocybin, and again a month later. The authors found that after a month, modest brain changes were visible relating to cognitive flexibility, psychological insight, and well-being. Archaeologists have uncovered evidence that early humans were already using fire in South Africa's Wonderwork caves between 1.07 and 1.79 million years ago. The previous discovery of early fire in the Kalahari Desert Cave system had been dated to around 1 million years ago. The new findings, reported in the journal PLOS ONE, extend the chronology of one of the earliest known records of fire use associated with hominids. Scientists from the Hebrew University of Jerusalem found signs of repeated fire use deep inside the cave, far beyond the reach of natural wildfires, suggesting that early humans were bringing naturally occurring fire into the cave and then maintaining it there long before they learned how to create it for themselves. To reach their conclusions, the authors used a new method based on light-emitting properties of burnt bones. See, when illuminated at specific wavelengths of light, bones that have been exposed to intense heat emit a distinctive glow, and that can be recorded by instruments. Well, we may well be heading for a Skynet future thanks to artificial intelligence, but it looks like there's a glimmer of hope on the horizon. A new study claims AI becomes more aligned with human moral reasoning the larger and more complex it gets. The findings, reported in the Journal of the Royal Society Open Science, assessed 75 large language models, including ChatGPT, Claude and DeepSeek, to see if they'd agree with human preferences when presented with life or death dilemmas. They found that the number of parameters a model was made up of affected how likely it was to agree with humans. The authors say the more complex the models were, more closely they aligned with human morality. But the improvements were gradual as the complexity increased. The dangers of lithium-ion batteries may soon be a thing of the past, as the next big development in battery technology, called Lithium Titanate, begins to make an inroad into the consumer market. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Now, these batteries actually have been in use by NASA and the military for some decades, but they weren't commercial or commercially available because the technology just hadn't advanced to a degree that you could replicate as easily as lithium ion. Now, lithium ion has a problem in that if you put a nail through the battery in the back of your phone, it'll have a runaway thermal reaction where you'll have this outgassing of very toxic gases. And we hear about people with scooters that they charge them inside their houses, they leave them on the charger all night, they maybe have third-party batteries, or the batteries themselves have been damaged because on scooters, you're banging on curbs and it's just a rough sort of environment for the battery. And they go off, and if people have died, their houses have been burnt down. And so people are wary of modern mobile batteries, especially if it's very cold, they don't charge. I mean, we heard about cars that don't charge in the very cold American winters. And lithium titanate has a few serious advantages. One, it operates in those minus 20, minus 30 degrees Celsius temperatures, which are very bad for lithium-ion batteries, and they operate at high temperatures as well. They recharge to full in approximately 20 minutes. If you damage them with a nail, or if they get broken in an airplane seat, they will not have the runaway thermal reaction. And then on top of all of that, a normal mobile phone battery lasts about 1,500 cycles before it starts getting to about 80% of its life and, discharges very quickly. We've all experienced a phone that is not holding anywhere near the charge you got when it was new. And of course, you can buy a new or third-party battery. But imagine if you could have a battery that lasted 10 or even 20 years before you needed to replace it. Lithium titanate batteries have a recharge cycle not of 1,500, but of 20,000 cycles or more. There are some robot prototypes from 30 years ago that are still working to this day because they had lithium titanate batteries. So Toshiba is one of the companies that is commercializing this, going to be using it in power tools that use rechargeable batteries. We'll see these things in cars and in scooters. And the company behind it have an operating system that can interface with any sort of battery and produce the correct sort of voltage for any sort of application. So it's kind of this universal translator between different sorts of batteries and different sorts of electronics. In the past, you had to match them very carefully and closely together. But with this operating system merged with this lithium titanate batteries, it's going to be the revolution we've been waiting for in battery technology. But it'll still take a few years before it's everywhere. But it's a great example of that famous saying that from William Gibson, the guy who wrote Neuromancer. He said, the future has already been invented. It just hasn't been widely distributed yet. Well, lithium titanate's time is on the very cusp of being widely distributed. And the battery problems of the past 10 years are going to fade away into non-existent. They'll be distant memories.
That's Alex Zaharov-Reutt from TechAdvice.life. And this is Space Time. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.